Cohen, and I'm here to speak to you about the expected business value in the quantum computing ecosystem. If you're hearing this, it's because I was not able to attend in person the conference on March 23rd, 24th in London, Innovations in Quantum Optics and Quantum Computing. So, made a presentation. So, who am I? I'm leading a quantum computing consulting startup after 30 years in IT management consulting and professional services. I've worked for IBM as an executive, Hewlett-Packard as a director, McKinsey & Company as an associate partner, and I've run a business as a managing vice president at Siemens. I started my career early on with KPMG Consulting. From an education perspective, a BA in economics from University of Chicago, master's in management from Kellogg, the graduate school at Northwestern University, and completed 4 classes in dissertation research towards a PhD in management sciences from the Stewart School of Business at the Illinois Institute of Technology. Today about the quantum ecosystem, quantum computing and quantum technology ecosystem, and we're going to talk about business use cases. And then we're going to wrap up with some suggestions on how industry or commercial enterprise companies should begin to work with quantum computing. So start with categories. From a hardware perspective, we look at full stack quantum computing providers, those who make a full computer. Then we look at component or solution manufacturers. So they make a piece of the ecosystem, whether it's quantum key distribution hardware or, let's say, dilution refrigerators or startups. We then talk about the software platform providers and tool providers. Then we have a section on access providers, so multi-vendor access cloud providers for quantum, and then consultancies and independent service providers. We'll then talk about the early business use cases, and by far the largest category is quantum computing optimization. So how to optimize a business process or a technology process or just math. Then you have non-optimization problems, ones that take advantage of the physics of quantum computing and use it to solve different types of problems. So not a QUBO or an icing, but a different type of problem. And then finally, there's quantum technologies that are not computing, things like sensing. And so we'll talk about all of those for you. Notes and acknowledgements. So all data we're presenting is publicly available. All the quantum use cases that we discuss are in the experimental stage or proof of concept. They're not in production. Our lists, and we update them all the time, may not be comprehensive as they're based on our team's experience and the research we've done. The providers that we list in the ecosystem are listed only once, even if they serve multiple markets. So we don't want to have duplication. So if they're a hardware provider, they're mentioned first, or software, they're mentioned in that section, and then subsequent sections are not repeated. So some of the providers and some of the use cases are leveraging quantum-inspired technologies, maybe quantum annealing, maybe digital annealing, maybe just simulation in general. And finally, the provider data is accurate or current as of February 1st of 2020, and the use case data is current as of October 1 of 2019. So now we're going to talk about the ecosystem of providers. So from a hardware platform perspective, you see a list of 12 providers here. Alibaba, Alpine Quantum Technologies, Atos, D-Wave, the list goes on. These are in alphabetical order. What I can say about this list is there's a lot of technologies being worked on. So for example, superconducting circuits, ion traps and photonics tend to be the leaders. And we'll see with startups, investments in neutral atoms and CMOS technologies, as well as some future-leaning things around spin and around topological qubits. Access methods are almost solely on-premise hardware, so they'll ship hardware to you. D-Wave and Fujitsu have done that. Or public cloud access. So you access their systems because they're rather difficult to manage and to keep up and keep available for you. Simulators today offer comparable performance. So many times we run our algorithms on simulators and then run them on an actual quantum computer. But we expect that as quantum computer performance improves, continues to grow, they will leave simulators behind. There's a lot of competition now between very, very large Fortune 100 public firms and small venture cap type private firms. And again, as we mentioned before, there are no commercial production workloads with quantum. This is really in the proof of concept or research phase. From a component or solution manufacturer's perspective, we see companies like Blueforce, who we've met with. They make the dilution refrigerators, or Hitachi, ID Quantique, and others, Toshiba, that work in quantum key distribution. You see companies working just on the quantum processing units or in other componentry. And it's a needed business to create a supply chain, a deep supply chain that can support quantum computing manufacturers and the use of quantum computers and secure quantum cryptography. From a hardware startup perspective, this list is constantly changing. We see companies that have raised $1.5 million, $2 million, $20 million, all the way up to $230 million for PsiQuantum. These companies tend to focus, of course, on one thing, and many of these are not transparent. And so what we really know is, in many cases, the technology they're investing in, we see a lot of neutral atoms, photonics, or CMOS. And we're excited to see startups being formed all the time. From a software platform and tool perspective, we see really players that were strong even before Chicago Quantum got into the business. Companies like Cambridge Quantum Computing, 1QBit. These are major players. Zapata and QBranch. And some of these have been acquired. And then you have more specialized players like Isara in the security space, and Strangeworks, work, and Riverlane working to build ecosystems. And then for Q Control and Quantum Benchmarks, they're really focused on the quantum manufacturers and helping them to develop and manage, so develop scalable systems and manage the inherent quantum noise in those systems. For multi-vendor platform access, you see Amazon and Microsoft, which were major entrants in 2019, and also QCware. So we know the team at QCware. We know that they offer platform services as well as software and consulting. And so it's an interesting list. So for consultancies and ISVs, there are many, many companies out there. You see Zapata, you see QuantPhi out of France, focus on financial services. We've met with them. Max Kelson out of Australia, really data analytics. We've met with them. HBAR, great team out of Australia. And then Boston Consulting Group and Accenture. Again, these are all firms we've met with, we've built relationships with, and they're out there working with customers. And so the one thing I'll say about this list is we know it's incomplete. We know that many, many companies are working on quantum computing. But to do this work, teams require diverse skill sets, ones that you don't find in a typical consultancy. You need physics, computer science expertise, math, industry domains, functional domains. And typically, even the leaders of the practice are doing programming and algorithms or working at that level to help clients solve problems. So growing ecosystem, you see a lot of big names and a lot of small players coming in. Now we're going to talk about early quantum use cases. So we had done this research really as we started our consultancy because we understood that quantum computing will only truly take off and be profitable for firms if we can show how using a quantum computer makes our clients more money. And so we're focused on that end case. So optimization, which is really linear algebra or just doing math to come up with a best answer, a lowest energy solution, a solution that maybe uses complex numbers and coherence and uses wave amplitudes canceling each other out to figure out the one or just a small handful of potential answers that we can then dig into. When we talk about a needle in a haystack, right? How do you find a needle in a haystack? Well, classically, you'd search the whole haystack sequentially. With quantum, in theory, you can search the whole haystack and look for the lowest energy solution, finding that area where the needle probably is. Maybe you run the problem a couple hundred times. You find the place where it finds the lowest energy solution or the needle in the haystack, and that's where you look. And so we see examples here optimizing travel routes, vehicle dispatch. We've seen it with bus lines. Optimizing a new car ordering configurator, any type of configuration system or recommender system. We've seen it with web as well, recommending ads. Waste and recycling truck scheduling, right? Increasing an automotive paint line capacity. Welds, optimizing the welding of seal joints and seams with robots to increase their efficiency and therefore the capacity of a line. We've seen work here on scheduling a complex repair shop. So you've got a repair shop, you've got orders, you've got a ton of backlog. Let's say you got $1 billion in backlog. If I can schedule the constraints, which is the equipment, the people, the ordering, so I'm matching orders to a flow through a repair shop, I should be able to earn more money from my backlog of repairs. We see many companies looking at portfolio optimization, so equities, fixed income, and using other diverse financial assets to build a lowest risk, highest expected return portfolio for customers. And so these are just a sample of optimization use cases that we found publicly listed on the web. We also see non-optimization cases, so verification and validation of complex software and hardware systems. So a quantum computer can find the points of potential breakage, and then you follow up with additional research to look at the potential failures of those systems. In validation, we see molecule and material discovery. So for batteries, pharmaceuticals, commercial compounds, we understand that quantum computers can be used to develop structures, functions, and even molecular comparisons. The way we like to think about it, we saw an example where you've got a disease, you got a virus, it's got a shape. If you can create a material that correctly bonds to that virus, you can stop it from bonding to the human body, or you can just make it no longer act upon the human body. And so if we can build that shape, we can use quantum computers to effectively invent that compound. Then we can do the wet work of actually developing those compounds to fit into that shape based on the structure defined by the quantum computer. And you can do accurate calculations and predictions of molecular properties using quantum computers. So that moves researchers much more closely or much more quickly towards a physical, chemical, or material that can be used. It could be used to price equities, options, and derivatives. We've seen that with quantum Monte Carlo analysis, the effective use of randomness, MRI scanner improvements. So we've seen this even with simulation technology, that we can either make our sensors more sensitive, or we can make them faster with the same sensitivity. We also have a use case which is interesting around just sensors out, sensing the atmosphere effectively. So then we can quantify client risk in new ways. We've seen a very large company, again, using quantum-inspired technologies, help a client go through a risk management protocol. And then radio access network signal processing, so connecting mobile user devices to core networks, especially targeted towards 5G networks, in a way that truly speeds up access between your mobile or your handy and those radio access networks. Then for quantum technologies in general, secure terrestrial communications from space and secure terrestrial communications on Earth. So we can secure communications with quantum technologies. We can enhance radar detection, microwave detection, sensors, and this work is going on, even now. So navigation without GPS, so truly passive navigation in a GPS-constrained environment. We've seen ultra-secure communications with photonics codes, quantum key distribution. We see a number of players in the space here. There's another way to securely communicate via the Earth's magnetic field. We've seen use cases around detecting movement and activities, both over long distances as well as within the human body. Picking lottery winners, picking truly random lottery or randomness in games. We've seen that as well. Atomic clocks. And then just something that we all appreciate, better TVs, LED displays, and lighting solutions using quantum dots. So what we've seen with the technologies is we've seen just a host of optimizations, non-optimizations, and then just general better use of the technology. Next, we're going to talk about commercial enterprise adoption and some of our thoughts in this area. So the first is, if I'm speaking to a client or a large commercial enterprise, I say, begin to learn about quantum computing. Just get comfortable with it. Typically, it'll be your data analytics teams that'll jump in. It also could be, let's say, your marketing teams or your research and development teams around new product development that understand that using quantum, things like quantum entanglement, quantum superposition, using the inherent characteristics of quantum technologies could really help. At this point, you haven't done anything with quantum, but you're just starting to learn about it and you realize, hey, maybe there's an impact here. Then you start to build a team of evangelists or volunteers. Eventually we see firms then hiring one or two experts. And so you've built a core team, but that core team is based on people around your company that have interest. Then identify and focus on one use case that would create significant value. One case, so really focus your efforts. Then start to tap into industry providers, academic institutions, scientific labs, and research groups. So we've even done that as Chicago Quantum, right? Working with the different industry players, working with different academic institutions like, our namesake, which is the Chicago Quantum Exchange at the University of Chicago. Just a tremendous academic resource, a consortium here in the Chicagoland area. Scientific labs in the United States could be DOE national labs such as Argonne and other labs. And then there's just general research groups. We've worked with the one research group, with a very, very large Fortune 100 company. And so as a client, you also have access to these great capabilities. And so make some investments, maybe adopt a postdoc or work with a lab to try to solve a problem. And then be visible. We strongly suggest use GitHub, be open and collaborative in your efforts. As one of my colleagues, Nick Farina, has said, companies can increase shareholder value by having visible, active efforts in quantum computing. We've spoken about the quantum ecosystem, and you understand that there's hardware, software, cloud access provider, and consultancies. It's a growing ecosystem of both very large companies and very small, nimble startups. We then talked about the use cases, and we see very specific public use cases out there. And then we talked about how a commercial enterprise should begin adopting quantum or quantum technologies. So what does it mean for us, for the academic, the scientific, the government agency, for students out there that are attending the conference? I would say be open, be collaborative, do a tremendous amount of networking. Use Twitter, use Reddit, use LinkedIn, use all the different networks, and build those linkages. This is a very small community and one that has the ability, the potential to change our business environment, our economy, to drive profound growth in business and societal effectiveness. And so, thank you very much for listening. And it is my privilege and honor to have presented to you today. This is Jeffrey Cohen, President, U.S. Advanced Computing Infrastructures, Inc., out of Chicago. Thank you.